Okay, so these are our two stories that we had to think about and find a way to represent in some kind of domain model. And the first kind of model that we're experimenting with is building up this table based on objects and messages, and then adding properties and outputs, making sure we're thinking about what is the behavior of our program going to look like. We're doing this to think about our process of converting requirements into software. So this is part of this process. We're doing it quite explicitly, quite intentional at the moment, as all these things that we're trying to practice and workshop together. It's very explicit with tables and lots of drawings and things like that. As we get better at it, we can skip some parts of this, but they're always really good tools when you pair or work in a team to do with each other. So this is a way that you can build knowledge with each other and make sure you're always on the same page. Also something that with a domain model, you can go back to the people who gave you the requirements and just double check with them. Is this something that in your eyes represents what we should be doing? It's always easier to confer and collaborate over diagrams than it is directly on the code. And then once everyone's aligned on the diagrams or the domain model, then you can convert into code. And usually there's some nice interaction between updating your domain model, updating your code, and things like that. So domain models aren't fixed, they do evolve over time. So remember that, you get it perfect straight up. In this example, let's build up our quick table here. So we have objects. On that first user story, we'd like to add items to the basket. So add looks like the verb and basket looks like the main noun. So I would probably jump straight into thinking about a basket as an object, oh, slightly thicker font, that's fine. Messages. This looks like some kind of add function that will take some kind of item. A simplest way to maybe represent this at the moment is to maybe keep this as like a string. Just have like simple string representations of an item. You might want to fully represent an item as a class itself. That's also fine. I'm going to try and keep it super simple. So we're going to have a function called add, which we've got to take something and store it someplace. So for that, I'm thinking that my basket is going to need some kind of storage. I'm going to keep an array, which is a nice, easy structure to store data. So this is going to be my properties over here for my basket. I'm going to need some kind of, let's call it items. Usually it represents the thing that it holds. So this name of the property will be items. It will be an array of items. So far, this is what I'm thinking. Basket, going to add items. It will continually add things to this array. So my output, I want to model in this case as whatever is the new added array of items. So I can imagine a scenario where I just like continue add one item at a time, and my output will always just be the new version of the array. All right. So quite simple for this first story. The second story, as a careful individual, so I can stay in good health, I'd like to know if my basket is full before trying to add another item to my basket. I have to think about a different output to my add method now. So you can model this in any way that you want, but what is the scenario that happens when the basket is full? I can't add another item. So you might want to return, you can do this in a few different ways. You might want to return just the same thing again, just without the added item. That might be one possible way to do it. You might want to return a message or some kind of information that says, like, if sorry, you can't add an item. Both are valid possibilities. I'm going to for the purposes of this example, I want to say I'm going to do something like give a string value, e.g. Sorry, basket is full. I'm going to use a string for this. We're going to keep it super simple. There may be other implementations where we can think about errors, actually intentionally throwing errors. We're going to avoid all of that for the moment and just try and be simple for this. So I've got another output now for my add method. It's either going to return the new array with the added item, or it's going to return a string that says, sorry, the basket is full. In which case I have to have some kind of check on what are the numbers of items in my array. And so if I need to check on the number of items, there has to be some condition that says, is it above or below a certain amount? So it looks like I now need to add another property here of some kind of, I don't know, limit or capacity to my basket array of items. So I don't know, let's call it capacity. You can call it max capacity, limit, whatever you want to do. And I'm using the at sign not in the right way for the moment. So let's not do that. It's going to be called capacity, and it's just going to be at the moment a number. So we're not going to have any decimal answers for capacity, not like a half an item. So let's give it an integer type capacity. So I imagine that when I use my add method, it's going to check on the capacity, and that might be all I need to do for this simple version at the moment in my add method. It's either going to add the item when it checks the capacity. It says, is it above or below? And if it's above or equal to the capacity, I'm going to return the string. If it's below, cool, we're all good. Let's add the item and return the new array. So another way that we can potentially model this, if we use like a sort of more of a sequence of events, called a sequence diagram, we could do something like this. Where we have our basket at the top here, and I'm calling the add item, and I need to get back out some kind of value, but there are two different possibilities here. I'm actually going to move this a little bit further down so I have a little more space. So the add item, in order for it to do its work, has to do a check, right? It has to do something like check the capacity is, I guess we should do it the other way around. Number of items in array, compare that against the capacity. And this will give me a value back, will either be true or false. So if we get true, we're going to get this back, or if we get back false. So if the number of items, if that check, this check here, comes back as true, Then we are still less than the capacity, so we can then return the list of items. Let's just do something like item 1, e.g. item 2, or the string that says sorry, etc. So this is another way just to think about the sequence of events that's going to happen when we use the methods that we've laid out. We call add item. It does a check first to see what are the numbers of items in the array compared against our capacity, which is a property. Both of these are properties. And there are two possible return values. It's either going to be a true or a false as a result of that comparison. And accordingly, we therefore have two different outcomes for our add method. So this is a way to represent these two stories in a functional domain model, and also using a box scenario, a sort of a sequence diagram. I did a sequence diagram rather than the box scenario diagram that shows how the objects will use messages to communicate with others. Let me pause there for thoughts and questions based on what I described here. How does it compare to the things that you're doing just now?
I just had a question as to why an item is not an object.
Can be.
Okay.
I'm trying to keep it super simple. I don't have any real reason to at the moment. The information in those stories doesn't necessarily mean it has to be. And so there's a tension between modeling reality, what we're assuming it should look like, and then just using information in the stories. There is an arguable case here to make that the item should be an object.
Okay, thank you.
I'm doing it intentionally because I know many of you probably did model it as an object, but also to show that you don't need to, but you can do. All right.
Hi, I'm a bit confused, like what the difference between like a message and a method is.
Yeah.
Just I was like confused, like why messages wasn't named methods in my mind. But there must be a difference.
Really great question. Think of them as synonymous. That's the easiest answer for the moment. All right. Messages comes from the world of thinking about object-oriented programming, that we send messages to objects. There's a sender and a receiver of a message.
Okay. So
the receiving object here for the message of add is basket. Basket receives the message.
Okay.
So we think about message passing between a receiver and a sender, and in this case, the basket receives the message add. So that's why I've written messages here, but think about it as being synonymous with the methods that the object needs.
Okay.
It's a slightly subtle difference in the way of thinking about messages where we send and receive in object-oriented programming. When you see that dot notation of like, I don't know, class, instance, dot, and then the method name, the receiving object is always on the left. We haven't yet come across a situation where that's inside of another function or another class, which would therefore be sending that message, but let's not worry about that yet. I'll point that out when we get to it. So at the moment, we're just using objects and they are receiving messages. Maybe a quick way to demonstrate that, actually would be if I added on the left-hand side here column another class, like maybe like, I don't know, an order class or some other kind of interface. Order would send the add message to basket. that might be a little bit too much for the moment. But let's not worry about it. Let's just worry about messages are sent to objects, and we can see that in the basket.add. That's a message being sent to basket, and they are synonymous with methods.
Okay, that was helpful. So I'm less confused now.
Good. That's always the intention. More direction, less confusion, progress. Other thoughts and questions?
Sorry, could you, on the mirror, could you disable the locked thing so that we could, because when I go on it, everything's purple because everything's locked. I don't think anyone's going to write anything on it. It's like, you know what I mean?
I think you may need usually is the changes, so you just have to hide the changes that have happened.
Ah, all right, thank you very much.
That's a good question. I know that can be frustrating, yeah. Unless you really like that color, which is fine. Any other thoughts or questions? So compared to the work that you're doing, thinking about this process, we're trying to get better at looking at user stories and trying to pull out important information and represent this in a domain model. And we've seen two versions of this now, using a table, trying to be clear about what are the objects, what are the messages, what are the properties, and what are the messages going to output. And also looking at a sequence diagram to try and organize our thoughts about what happens at what point. You can also represent some of this information about the order here using the two different, I'll talk about this a little bit later, that's fine. Okay, so the next step after this, once we've got here, just spend a little bit more time with it this morning by yourselves, having a look at it, trying to make sure that you're confident in these specific user stories and in the way that this information is displayed here, making sure you feel confident about that. And then this morning, if you want to continue with this process, I want you to do these two steps down here of further work. Using this domain model, I want you to think about a set of tests using the test framework that you created yesterday in the way that we were using it yesterday. And then after you've written a first test, then write code to make them pass. So that can be extra work. After you feel confident on the things you've just been doing, then write some tests and write code to make them pass. So that's things that you can do this morning. Otherwise, I want to spend 5 minutes introducing the other work for this week. Was it here? Yes, it was. Cool. Okay, so we're going to spend about a week and a half on this project, and you'll pair with each other. You'll do it by yourself, and so you'll have a bunch of work on this project. Project's called Bob's Bagels. Who likes bagels? Couple shakes the head, couple thumbs up. I spent about 5 or 6 years in New York, and so I'm a huge fan of bagels. Especially New York bagels. Anyway, we're going to continue, as you might imagine, from very similar to some of the things you've just been doing, to implement a basket feature. And this is, as we've been doing, just not thinking about interfaces, not thinking about anything else like this, just writing tests and units of code for them. So it's going to practice your ability to take user stories, create a domain model, add to a domain model, keep updating it, and then test driving, just making sure we're practicing this process of converting stories into a program, and making sure that we are test driving it. So these are the first set of user stories. You can do the exact same process. They're slightly different to the ones you've just done. So go through from scratch, create your user stories, and then write your first test and get them to pass. Spend a little bit of time making sure that your domain model is useful, is accurate, and then keep updating as you go. There are 3 parts to this for the first stage. So this is what you'll do this afternoon. And if you want to spend some time having a look at this morning before you pair on it, I advise that. So maybe spend half an hour, an hour, however much time you want, just look through it, play around with it, so you have some sense in your head before you start pairing on it this afternoon. I see a hand raised. Yes.
Sorry, that was me saying I like bagels.
Good man. Didn't see that. So that's what kind of bagels? What topping and what kind of bagels your favorite, Eugene?
I don't know if you've heard of Bagel King. They do like jerk bagels.
Ooh, okay, that's an interesting one. I haven't had that before.
It's really nice.
That's pretty good. Anyone got any other favorite bagels, bagel types?
I like cream cheese on bagels. Yeah. I think I like Montreal bagels more than New York bagels.
All right, controversial, but that's fine. Cool. Okay, does that give everyone enough things to be focusing on this morning until we gather back at 2 o'clock?
Can I ask one question then?
Yes, Richard.
When we make the program from before on the previous page, I forgot what it was, but there's like a few methods that we have to write tests for. Do we need to have like a different spec runner for each method, or would they all be bundled together in the same directory? Or
have a go. The information I'll give you for the moment is every class should be in its own file, and correspondingly, each class should have its own spec file.
Okay, only the class. Okay, fine.
Yeah. So we should always be thinking about classes and not just functions. We're practicing object-oriented programming. And then on top of that, you should never need one spec runner. All right, the spec runner just runs all of your specs. And so you should be thinking, rather than the spec runner, thinking about what specs should you have. And correspondingly, if you just have a basket object and that's it, you should only have one spec, which is your basket spec. Inside that basket spec, you might have many tests.
Got it. Thanks.
Good question. Any other thoughts or questions? Does everyone feel like they have a direction to head in until 2 o'clock? Cool.
I've got a question about the spec.
Yeah.
So yesterday we started with like the test framework JavaScript file to obviously make it true or false. Do you always start with that code basically to obviously to provide a test and before we start writing the spec?
Yeah, for the moment, all we need is that comparison function to assert that 2 things are equal to each other. Now, clearly, we'll use that function to compare the result of the add method to what we want it to do.
Right, okay, yeah, makes sense, cheers.
Cool, good question. Any other questions at the moment? Cool. All right, so I'll see you all at 2:20. I'll send a prompt at 2 o'clock just so you can all organize into your own peer groups and then share in your Discord channel the outcomes of your stand-up, and then I'll see you at 2:20. Bye for now.
Sorry, I was going to ask, what time is lunch?
Lunch is, you can have lunch whenever you want, all right? Make sure you're eating, and that's absolutely fine. Ostensibly, we've blocked out 12:30 to 2 p.m. Cool. See you all later.